Hello everyone, my name is Emiliano Larach, and today I'm going to be going over Physics 2212 lab number 1, which we will be talking about charge tapes and electric forces. On this lab, we will be analyzing electric forces by using two pieces of tape, which we will charge by ripping apart from each other and then trying them against different surfaces and against each other. First, I'm going to go around some basic physics principles, some formulas, and a free body diagram so you can understand what are we doing. Next, I'm going to analyze the code that I use to describe what was happening in the real life with a computational model, and then we're going to go through some of the results that we got. First of all, as I said earlier, we were going to be talking about electric fields, and how can we analyze the force that is experimented by these electric fields? We can calculate this force by using Coulomb's law, which you can see here in the screen that I'm pointing. This is how to calculate the electric force on one object caused by another object. We're also going to be talking about excess charge or deficient charge, depending on if a material loses or gains electrons. Also, as we know, the force due to gravity will be helpful in this lab, and the electric field formula that helps to calculate the electric fields generated by one point particle. Also, it's important that also we can calculate the force that an object's electric field is exerting on another one by multiplying its electric field by the charge. So by multiplying the electric field by the charge, we get the force generated by that. So the measured distance when we this is one of the diagrams when we took our tape A to tape B, we figured that both of them were positively charged. So when we put one of them closer to the other one, they were repelled. So tape B lift up, and we measured that the distance for this to happen was 0.005 meters. Our mass of the tape was 2.05 times 10 to the negative 4 kilograms, and the length of the width of our tape, you can see it on the screen. This is some of the code. This was based on our lab 0 activity. I just had to modify a few things, such as the print, what it had to print, and also modify the mass of my tape. This is the output, so you can see the forces acting here. This is tape B, and this is tape A and tape B. We can see the force of gravity, and the orange is the electric force acting on both of them. As we can see, they are repelling each other, so one goes upward. That's why tape B is lifting the other one, and tape A, this one, is going downwards because they're repelling each other. If we calculate this, the computational model gives us a result of minus 1.857 e to the negative 9. This is in coulombs in charge, and when we do the calculation by hands, we get a similar charge of 1.857 coulombs. This we get it by using by setting force of gravity equals to force electric, and then solving for QB, which is the charge of tape number B. Then to calculate the area of the tape, you can see the calculations. We found that the number of atoms of the tape was 1.43 times 8 to the 18 times 10 to the 18. We just divided the area of the tape by the area of one atom, and also we found the number of electrons to be 1.16 times 10 to the 10th power. The two main assumptions that were made in here was that the tapes were treated as point charges. Obviously they're not, but we treated as if they were, and we assumed that the U tape had the same charge everywhere, evenly distributing about the length of the tape. Some of the discussion questions are, what if the electrons have positive charge and protons have negative charge? This would not change the observations we made with our tape. It would just be like a convention change in physics. So negative is changed by positive and vice versa. And it is important that we had handled the tapes with as little contact as possible, because our hands can evacuate some of this excess or some of this charge that is not on the tape. So our hands would act as a pathway for these electrons to come back into the tape, and our charge that we positively charge them would be lost. So it is important that we have little contact with our hands, so we don't lose that charge that we generated.
As a finishing note, I would like to stand out that this experiment is not perfect, and there might be some error points, such as in measuring the distance at which one tape acts on the other one. Another possibly error point is our experiment setup. From our initial conditions, which were two positively charged tapes, we could have made some mistakes while setting them up. We also have to take into the consideration the possible errors introduced by the different surroundings, not just our system, which are the two tapes.
That is all for my lab video. I hope you enjoyed it. Thank you for watching.